We're going to continue working with the pop quiz example and try to answer some of the questions that we first looked at back at example 92. So to help us out with this, all I'm going to do is sort of write out a probability distribution that contains the probabilities we calculated in example 93. So x could take on the values 0 through 4. And we found these values when we worked out the probabilities. So in part A, what's the probability we get more than half right? So more than half right means we're interested in what's the probability that x is 3 or 4. And since these are mutually exclusive, these values for x, I'm either going to get exactly 3 right or exactly 4 right. They can't both happen at the same time. I can just add these probabilities. Get 0.1111. In part B, what's the probability we get them all right? Well, this is just the probability that x is 4. And we computed that to be 0.0123. So pretty small, about a little over 1% chance of getting them all right. And in part C, it says if the entire class guesses on the quiz, what should the average number of correct answers be? And really, we're thinking of as an average, like the mean. You know, what if I sort of tabulate how many correct answers everybody ended up getting on the quiz, what should I get when I compute that mean? Well, since we do have a probability distribution here, we know how to find the mean as the sum of the x times p of x values. And so let's work this out. So I'm just going to add up the products, right, for each of these rows, x times p of x. Let's see what we get. So this first product here is obviously going to be 0 because we're multiplying it by 0. So I'm going to start off with the second product. And I get 1.3333 for mu, sort of the average number of correct responses. So a little more than 1. So basically what this means is on average people get 1 or 2 questions right on sort of how we would interpret this. Mu is taking on, because of the way we compute it, could take on values even that x cannot take on. And then this last one, how many can you expect to get right? So let's think about sort of how our gut tells us to approach this. How many can we expect to get right? Well, we could think of it as we've got 4 chances, right? 4 questions to guess on. and a 1/3 probability of being right on each one. So I would think that the number of questions I could expect to get right would be 1/3 of my 4 chances. This is 4/3, and if we do the division, we can approximate it to 1.3333. It keeps repeating, but notice that we got the same response here. This is in fact not a coincidence, and we're going to delve into this a little bit more toward the end of this section. But in sort of theoretical sort of probability theory, the term expected value and the mean are synonymous.